Hello. Today we consider two algorithms, two search-to-sparse algorithms, Floyd-Warshall and A star. So let me begin. Так. Okay, the Floyd-Warshall algorithm. Do you see demonstration? Yes. This algorithm solves the all path pairs shortest path problem on a directed graph. So before this, let G is the directed graph and V W is some function from H to R to real numbers. Так, solves the all pairs. The all pairs shortest path. Problem on directed graph. Directed graph G with negative edges, with negative weight. But without negative cycles. So, as this task, this algorithm uses the pair, just we just as we did it in the Bellman-Floyd algorithm, the Bellman, сейчас, Bellman. Where is the Bellman? Bellman-Ford algorithm. We use the pair. In this case, we use the pair too. But we will use 3D array, the pair IJK. What is the pair IJK? It contains mean costs, mean lengths, lengths from E to G. um, false intermediate vertices included are drawn from set 1 to k. So okay, this is our DP 3D array. So we need to allocate base. Where's my pen? Okay. Base will be dpi g null equals to, we don't take any vertices, so if there's an edge, we took this weight. Otherwise we took plus infinity. So, and we're going to consider layers. We calculate layer by layer with this slice of array. So the PEG, we need to we use ordinary DP, not forward. So this is there are two cases. Just obvious case when we consider only k vertices, only vertices that number less than k, and we consider another case when we included k plus 1 vertex. So we necessarily include k plus 1 vertex. It means here will be, here we need to include vertices that number less than k, and here too. So why is it true? Why we don't use k plus 1 twice? Because there's no negative cycles. So our DP will be, when we necessarily include vertex k plus 1, DP и жk plus 1 k plus what? Plus DP k plus 1 g k. Easy DP, we think. So okay, the order is trivial. We just calculate the pair layer by layer by k. So complexity will be O(n) squared if n is count of vertices. So the memory. What will be answer? Answer will be in the P E G n. What is n? We include all the vertices to this path, and we calculate our dp, our shortest path. So we need to improve memory. Memory will be O(n) squared. It obviously improved by O(n) squared or O(n) squared. Okay, and if we take only two layers of dp k and k plus one layer. So, but in this case, we can improve it by only one layer. So let me show you how to do it. We gonna store in this array the p values. The p values are stored in G. So the algorithm will be for k1 to n, for e1 to n, for g1 to n, g и g equals to mean g и g and okay, g и k plus g kg. It's very similar to how we calculated our dp in the first case, but in this case we calculated our dp, our g, by itself. We notice that we, in this case, if there is k, g e k equals g e k equals to g e k plus g k k. So it will be g k k is null. It means in each iteration we get that g e k row column and g k g row doesn't change at all in every iteration, in whole iteration. So this will be this will be worked correctly, but let's do a statement. after case iteration of outer cycle G ij j equals to dp и g k. Oh, I have already prove it by words. In G и K, G и K plus GKK. It equals to null, so we get that this value, this sum, if we consider layer E G KK, this row and this column doesn't change in whole iteration. That's why we can calculate G our dp like this, in such way. So how can we construct our shortest path? Consider some path, and notice that at the moment G и G assign just at the moment G и G assigns we can contain our vertex, our vertex are like this. So just one second. If we imagine our path, if we notice that in this case, in this line, we last time when we update our GJ by k, by some k, will be include this k, will be include vertex. So we create some array that contains only vertex with highest number. So to construct the whole path, we need to use idea that we use when we construct paths, or some paths from O to where we just call recursively p at where and get the whole path. I think it will be works like this. Path pass e, we recursively call pass e p g, then we print pg, and then we call pass from peg to g. So to print the whole pass, we need to just print e, then print pass e g, then just print g. So that's all. That's the whole algorithm. Do you have questions? Any questions? How do we construct pass, or how, or why is it correct? Is this works correctly? This order. Once again, we consider the Floyd-Warshall algorithm that solves the all shortest path problem. So we consider the pair, then we improve our memory, then we improve our memory and create only one layer. We can improve this memory easily by create only 2 layers, but in this example we create only 1 layer and proved that this calculation of the pair works by using just the statement. And yeah, I described how to construct all the passes, all the shortest passes in this algorithm. So this will be works for on squared. The next is A star algorithm. Did you ask questions? Okay, you didn't. Next we consider A star algorithm. This algorithm uses everywhere in when we consider the first lecture, when we consider the FAS. A star will works very efficient. Do you see YouTube or not? Okay. Here's A star. So A star uses in games and everywhere. So to use this algorithm is not universal. In every task we need to come up how to create function calls heuristics. So to use this algorithm, we need to know about our task. Shortest path problem. From S to T. Again, where I change v by edge now to infinity. Not infinity, infinity included. Okay. This algorithm is similar to Dijkstra. In your homework, I think you already look at your homework. In your homework, you have task. In this task, you change Dijkstra. You want to change Dijkstra. So complexity works for OW plus E. How it works in the Bellman-Ford algorithm. So and in this task we are going to change Dijkstra algorithm to A star to solve to как бы сейчас one second. Okay, we just want to improve our Dijkstra algorithm. So it's similar to Dijkstra. So we consider some S and C. Once again, we consider we want to find paths only S from S to T, and in this case we create two functions. HV calls heuristics that different in every task, and GV is usual function that we used in the Dijkstra algorithm. It was some idea how to воспринимать this task. GV plus HV. And we create and we are going to store this function in our heap. So A звезда, A star is Dijkstra on this function. We in usual Dijkstra we consider only this path from S to V, from S to all V, and we update. We're trying to estimate the distance between S and V. In this case, we consider trying to we're gonna try to estimate GV plus HV. So H is a heuristic function. Non-formal measure of similarity. And G GV current founded all the lengths from S to M. How we did it in usual Dijkstra. So I provide you a pseudocode. Vector double G, usual G, and vector. I use this denotes because in every literature it calls G and it calls F. So Gs will equals to null, and f of s equals to hs. Hs is a heuristic that we declared, that we defined. It depends on our task. So we create heap q. This q store vertices order by f. In usual Dijkstra we consider heap order by G. So usual code while q is not empty. It's not empty. We extract minimum from our queue. And then do relaxation h a in graph, in our graph where we consider x that equals to GV usual Dijkstra, GV equals, and in this line on it to relaxation, and then in the following lines there's difference. There will be difference a little bit. GTV je2 equals to x, it's usually the extra, and f e2 equals to what? Equals to x. It's f is sum. It's sum x plus our heuristic function plus our heuristic function h e2 e2, and we just push e2. And by the way, there's an optimization in the extra algorithm, in a star algorithm. We push e2, but consider case for example, сейчас plus infinity блин. Consider this case. In our queue, we contain 1 and 3 vertices. Then we push this vertex, and we delete this vertex from our queue. 1, 3, 2, we delete this vertex, and then we consider these vertices, and we updated 3. Then we want to update this vertex, but but in this case we just push new vertex 2, but this vertices v and v are the same. So if there's a vertex, we want to delete, we want to decrease key. We want to decrease key of this vertex. Decrease key of e2. If there's сейчас if e2 okay. So, do you have questions about heuristics function? I can consider examples. I can consider examples, and in these examples we do you know what is Manhattan distance? On math analysis you must to learned in math analysis. Okay, okay, in this example, when HV is silly, it's equals to, it's always gives you null. In this case, A star degenerate to Dijkstra. No, this line is useless. Okay, when it's dist it equals to dist vt theory function that equals to dist. It is da a star. Consider only non-formal, only pass from S to T. Why is it not formal? Because we in this case we сейчас как будет. В любом случае we consider edges, and we consider not only pass but edges too. Okay, and if the task on R2 we can consider Manhattan distance. Our function will equals to Manhattan distance. Блин. Так. H at V equals to так. And this is very useful in games where you for example, if you have some plane consider S and T, you can move like this, and you need to use this Manhattan distance to get correct answer. By the way, in this video we they uses Manhattan distance. So, and just okay, let me just write like this: x minus x1 x2. And usual Euclid distance. Блин. So I think you have intuition about a star a little bit. So we consider improvements, how it works. I think it's possible to combine the ideas that we can use O and V complexity plus V plus E in this solution, in this Dijkstra solution, and Ладно, потом. Okay, let's create some definitions. Так. Heuristic function h is admissible if h were less or equal than dist vt. And another definition of a heuristic function. Heuristic function. Heuristic h is what? Is monotonous. If ht equals to null and there's неравенство треугольника, triangle inequality performs hu less than hv plus vuv. What it means? We consider ut and v, and this way is less than this way, this volk. So, but there is a note. We can use monotonous heuristic functions. We can use admissible and admissible functions. And notice that monotonous functions, monotonous heuristic functions is admissible what we can do for prove this statement. So we consider this inequality. We want to prove this inequality using this. So base ht is equals to null is true. Ht less than dist vv equals to null is true. And second, hu less than okay, let's for each UM let shortest path where p is shortest path from v to t. So it equals to p equals to v, v1 and so on, and t is shortest path from v to t. So to prove this statement, we just prove inequality. We use triangle inequality a lot of times, a lot of time, and get that v2 v1 plus v1 v and so on, and so on, v1 v plus w v1 v2 and so on, it equals to dist vt. It equals to dist vt. It means this monotonous heuristics are admissible. So we are going to prove theorem about this heuristics. If H monotonous, hence A star always finds the answer and open each vertex not greater than 1. What I mean by open? I mean by open this cycle, this condition for every wedge. So when we consider all the paths from some vertex, it means we open this vertex. So we open each vertex not greater than 1 and get appropriate complexity. So if H is admissible, then A star always finds the answer but perhaps in exponential time. When our heuristics is so bad, but if H isn't admissible, hence A star can find quite non-formally quite good answer approximation and quite good and in quite good time. What I mean by quite good? Almost the extra. You can improve your heuristics again and again, and it can be non-admissible, but in real life, by the way, you use this non-admissible heuristics and improve it again and again in complex tasks and get approximation or some approximations answer for quite good time that works for like the extra. So usual the extra. So this will be without proof because it's too it's silly, it's hard and not interesting at all. So we gonna consider only this improvement. But before this, we prove lemma about to prove. Сейчас. I think I will give you this proof of this theorem in your assignment. So you prove this lemma. So you prove this theorem by yourself using this lemma. H is homotomous. It means sequence of f values you get for your test very few a few points, and I will give you assignments instead of test, instead of как бы, чтобы набрать побольше баллов. Heap is not decreasing. So let v is extracted. Once again, we're gonna prove this lemma, and you in your in this theorem will be x. Okay, and who will be the first who solve it? get not so hard theorem, so you get 2 points for this. We just use this lemma. H is homotomous, monotomous, homotomous. Monotonous. Sequence, hence sequence of the values extracted from heap is not decreasing. In this cycle, you extracted some vertices and get that, and let ways extracted from heap. It means Fu greater than Fv for every U. So we consider this a vertex and open it, and we get that here we get GV, and here we get GV plus cost, plus some cost V W V2. So F2 F2 can be equal to G V plus cost plus H2, and this will be greater than Fv. And that's all proof. That's all the provement of the proof. Very easy lemma. Okay. I forgot something or I didn't forgot. Do you have questions about A* algorithm? Once again, heuristic function is different in every task. It can be replaced by assigned by Manhattan distance or Euclidean distance in R2. Okay, and we prove some facts about we consider some heuristics, some different heuristics, and here I suggest you 3 theorems, and the theorem you can prove by yourself is using this lemma. Okay, you can prove not the first people student get 2 points, all of all of them. So who proves this task? So that's all. I think I consider it. Floyd-Warshall in star. So that's all. You're free to go.